Diving into the vastness of space, there is an extraplanet called Proxima b that has a mass very similar to the Earth and is located in the habitable zone of its star, Proxima Centauri. The closest star to Earth after the Sun is a red dwarf located 4.23 light-years away from our Sun. Recently, with the help of the new James Webb Space Telescope, lights are being detected coming from the exoplanet Proxima b, which could be the latest proof that it's inhabited by extraterrestrials. However, this is not the most incredible discovery that the James Webb Space Telescope could provide us with about Proxima b. What will our new telescope discover on Proxima b? And how would this affect the possibility of sending a manned mission to this exoplanet? Stay with us to find out about this mysterious discovery by the James Webb. If you are interested in keeping up to date with news from the universe and its surroundings, subscribe to our channel. Be sure to like this video and turn on the notification bell. Now, what is an exoplanet? An exoplanet is a planet that orbits a star other than the Sun and therefore does not belong to the solar system. Of all the exoplanets known so far, none arouses as much interest as Proxima b as mentioned above. The star orbiting this exceptional planet is Proxima Centauri, a very cool red dwarf with a surface temperature of 2,872 degrees Celsius, 8 times less massive than the Sun and 500 times less bright. About 7 million kilometers from its star is Proxima b, which has characteristics very similar to those of the Earth, with continents, oceans, and probably life, with greenish auras giving the planet a greenish color in both atmospheres as a result of the intense flares expelled by its star, forcing the magnetic field to generate these huge northern lights. This planet is tidally locked, that is, the same face of the planet always points to its star, as happens with the Moon and the Earth. This means that the best area for life is a twilight zone. The surface temperature could be between -90 degrees and 30 degrees Celsius. It takes about 11 Earth days to complete a full orbit of its star, and it has a gravity of about 1.3 times that of the Earth. Scientists are not yet clear whether Proxima b has an atmosphere, but if it does, the ingredients such as carbon dioxide, rocks, and water necessary for the formation of the biochemical cycles we call life will be present on its surface. As of today, manned missions are impossible, but a project called Breakthrough Starshot, supported by billionaire Yuri Milner, is being worked on to create nanoprobes that travel at 20% of the speed of light to visit our neighbor Proxima Centauri. Estimating that the speed of these nanoprobes would be 16,000 kilometers per second, it will take a few decades to arrive, but it will help our future generations discover secrets about the star Proxima Centauri and its exoplanet Proxima b. What would these nanoprobes find when they arrive? Well, it turns out that we have been receiving signals from Proxima Centauri. The detection was picked up by the Parkes radio telescope while investigating the star because it was emitting strong flares that caught the attention of Anderson of the University of California, who led the Breakthrough Listen project funded by Yuri Milner, which consisted of searching space for technological civilizations. This project is known as the Search for Extraterrestrial Intelligence, or SETI. They began collecting and storing all the signals they discovered for their ongoing research, until Shane Smith, a young college student at Hillsdale College, began examining the data until he stumbled upon the curious 982 MHz narrowband radio frequency emission hidden from view in the Proxima Centauri observations. From here, Sophia Sheik of Penn State University took over the next signal analysis from the project and said, "This is the most exciting signal we found with the Breakthrough Listen project because we haven't had a signal jump like this in our data before." A cluster found by about 40 galaxies, and this cluster belongs to the local supercluster with approximately 100,000 galaxies. Well, it is estimated there are approximately 10 million superclusters. After knowing this, just imagine that if the Milky Way is not a very large galaxy, and there are already 55 confirmed potentially habitable planets, imagine in all these superclusters, and in the infinity of the observable universe, the number of habitable planets or even planets with life that may exist. The importance of discovering exoplanets lies in the fact that it helps us better understand our place in the universe and answer fundamental questions about life and existence on other planets. The discovery of exoplanets allows us to explore the diversity of planetary systems and discover new forms of life that could exist on other planets. In addition, exoplanets can help us understand how planetary systems form and evolve over time. There are also important implications for the search for extraterrestrial life, as exoplanets are candidates to harbor life. They can provide information about the conditions necessary for life to exist elsewhere. Finally, the study of exoplanets allows us to test our theories and models about the formation and evolution of planets and stellar systems, which helps us advance our understanding of the universe and our place in it. If you liked the video, do not forget to subscribe, hit the like button, and if you have any questions, leave them in the comments below so we can interact with each other. See you in the next video.